In this video, we are going to put all those things that we learned in this unit together and do some application problems. The first one is about a construction worker which drops his wrench. Its fall is modeled by the relationship given here, where h is the height above the ground in meters and t is the time after the wrench was dropped in seconds. We are supposed to describe the shape, position, orientation of the graph. As we said before, to plot this graph, we need to know the vertex because we know it's a parabola. We never talked about a shortcut to find the vertex. To find the vertex, usually we factor out the quadratic, and then from there we can change it to vertex notation. Another way of doing it is to find the x-intercepts, and then by taking the average of the two x-intercepts, we can find the x-coordinate of the vertex, and then sub it back in the equation, we can find the y-coordinate. Another technique, which is a shortcut, which is very good and very fast, is using this formula, which says that the x-coordinate of the vertex, which I showed by v sub x, is equal to minus b over 2a. Remember that the quadratic equation in general is y is equal to ax squared plus bx plus c. A is the leading coefficient. In our case, a is negative 4.9, so I'm going to write it here. B is the coefficient of x, but there is no x in this equation, so this means b is 0. And c is the constant, and the constant is 342. So I can use this equation, the shortcut, and the values given here, and I can find the x-coordinate of the vertex. So I can say that v sub x is minus b. B is 0, so it's 0 over 2a. A is negative 4.9, so it's 2 times negative 4.9. 0 divided by any number is going to be 0. So we know the x-coordinate of the vertex is 0. This means that the vertex is going to be on the y-axis. So now that we know the x-coordinate of the vertex, I put it back into the equation and I find the v sub y is negative 4.9 times 0 squared is going to give me 0 plus 342. So the vertex is going to be at 0 and 342. Now, our graph goes by 1, 2, 3, 4, and so forth. Because 342 is going to be much more than, the size of the graph, I'm going to renumber these, and I'm going to call this one to be 100, this one to be 200, this one to be 400, and so forth. And this is 600, this is 800. Now 342 is going to be, this is 100, 200, 300, so it's going to be somewhere in the middle. So this is going to be my vertex here. Now I need to find other points too. For instance, let's try to find the y-intercept. The y-intercept is when x, or in this case t, is 0. This is t, this is y. When t is 0, y becomes 342. So this means that the vertex is the same as the y-intercept. So y-intercept doesn't really help us. Let's try to find the x-intercepts. To find the x-intercepts, I'm going to let y equal to 0 and solve for t. So I have to solve 4.9 t squared plus 342 is equal to 0, negative 4.9 t squared is negative 342. Move this one to the right. So t squared is negative 342 divided by negative 4.9. If we take the square root of this one, we get plus or minus 8.4. Now, since we are dealing with time, time cannot be negative. So this negative 8.4 is not acceptable in the context of the problem we have because t represents time. So the only x-intercepts I have is 8.4. 8.4 is going to be somewhere in the middle. Now, our graph, I can try to find another point here too. For instance, I can assign t to another number, and I can find another point. But having these 2 points, I can just draw, part of the parabola which goes through these 2 points. The next part of the question says, how far above the ground was the wrench when it was dropped? We can easily find that by either the y-intercept, which is 342, is the answer, or we say when initially the wrench was dropped, the time was t equal to 0. If I sub t equal to 0 in this equation, negative 4.9 times 0 is going to give me 0, so the answer is going to be 342 meters. So the wrench was initially 342 meters above the ground. The next part of the question says, how far was the wrench? Has wrench fallen after 5 seconds? First of all, the equation is h is equal to negative 4.9 t squared plus 342. After 5 seconds, the height of the wrench above the ground is negative 4.9 times 5 squared plus 342. If you use your calculator, this becomes 219.5 meters. But the question is, how far has the wrench fallen after 5 seconds? This is the distance of the wrench from the ground. So we have to subtract this from 342 to see the distance that the wrench has traveled. So 342 minus 219.5 is going to give us 122.5 meters. So the wrench has fallen 122.5 meters after 5 seconds. The next part of the question says, how far has the wrench fallen after 10 seconds? And how can we interpret the answer realistically? After 10 seconds, we have to evaluate the function h is equal to negative 4.9 t squared plus 342. If I sub 10 here, I get negative 4.9 times 10 squared plus 342, which is going to give me a number negative 148 meters. Now, in the context of the problem, this negative doesn't make sense. The only way that we can interpret this one is that if the wrench has fallen into something like a lake, so it goes in the water, or it has fallen into a well. Otherwise, this answer doesn't make sense. The next question is, when will the wrench hit the ground? We have already done this one. This is the x-intercept, meaning the equation, which is h is equal to negative 4.9 t squared plus 342. When it hits the ground, h becomes 0. So this has to be 0. If you solve this one, t squared is negative 342 over 4.9 negative. If you take the square root, you get two answers, but the negative one, we drop it because time can't be negative, and the answer becomes 8.4 seconds. Now, this explains the previous problem, which says after 10 seconds, because it takes 8.4 seconds to hit the ground. So 10 seconds is going to be more than 8.4. The next problem says a football player kicks a football held 0.5 meter above the ground. The football reaches a maximum height of 30 meters at a horizontal distance of 18 meters from the player. We are supposed to find a quadratic relation that models the path of the football. So let's assume the ball is originally here. Let's draw our coordinate system such a way that the player is here standing at the coordinate system here, origin. This one is 0.5 meters. The football goes up and comes down. The maximum is 30 meters, 18 meters from the player. So this means this is 18 meters and this one is 30 meters. So I know the vertex is at the point 18 and 30. And also I know that the point 0 and 0.5 is part of the graph here, where the ball is initially is. Now I have to find the equation. I know the vertex form of the parabola is y is equal to a x minus h squared plus k, which is a times x minus h. H is 18 here, plus k. K is 30. And this is my y. Now to find a, I'm going to use the point 0.5. So I'm going to say 0.5 is equal to a times 0 minus 18 squared plus 30. Now, this gives me 0.5 is equal to 0 minus 18 squared is 324, a plus 30. If I move this one to the left, I get 324, a is equal to 0.5 minus 30 is minus 29.5. So a, if I divide by 324, both sides, I get a is approximately going to be equal to negative 0.09. So the equation becomes y is negative 0.091 times x minus h, we know h is 18 squared, plus k, and k is 30. So this is the equation which models the movement of the football. The next part of the question says, at what horizontal distance from the player does the football hit the ground? When the ball hits the ground, y value is 0, so I have to solve the problem. Negative 0.091 x minus 18 squared plus 30 equal to 0. I move 30 to the right and divide by negative 0.091. So I get x minus 18 squared is equal to negative 30, because 30 becomes negative, divided by negative 0.091. Now, negative over negative gives me positive, so I can cancel them out. Now I take the square root of both sides. I get x minus 18 is equal to square root of 30 over 0.91, which is going to be plus or minus because I take the square root. So x is equal to 18 plus or minus square root of 30 over 0.091. There was a mistake here. This is 0.091. If we go with the positive or negative, if we find the square root of 30 over 0.091, the square root plus 18, I'm going to get approximately 36.2. If I go by the negative, which is indicated here, 18 minus square root of 30 over 0.091 is going to give me approximately 0.2. But remember that we are having a round of error here. This 0.02 it's supposed to be 0 because this is the time that the player shoots the ball, football. So this one is okay. This one is the time that is going to take the ball to hit the ground, which is here. So the answer is 36.2 seconds.